Yep, next up, I'm going to introduce António Ramires, who's going to speak to us about some of his research. He, as he mentioned kind of at the beginning, he is currently the lead researcher at Beatoven.ai, and he recently completed his PhD at the MTG in UPF in Barcelona. And his thesis focused on creating unique methodologies for characterizing and generating samples for electronic music production. And today he's going to talk about how deep learning can improve sample retrieval for electronic music creation. So super excited to hear what you're going to tell us about today, Antonio. Feel free to share your slides and get going when you're ready.
Thank you very much. Can you see the slides?
Yes.
Perfect. Yeah, thank you very much for the amazing introduction, Christian, and for the invitation to be here, and for all the beautiful presentations that happened before this one. My name is António Ramires. I'm the lead researcher at Beatoven.ai. As Christian said, I recently finished my PhD in Universitat Pompeu Fabra, and now I'm working full-time in Beatoven.ai, which is a startup working on automatic music generation for background and royalty music for content creators. And today I'm going to be talking about how can deep learning improve sample retrieval for electronic music creation. And yeah, because we just have 15 minutes of presentation time, I'll just be presenting a non-exhaustive overview of some of the algorithms that can be used, the deep learning algorithms that can be used for helping browsing sample collections. And I'll be posting papers and references, so make sure if any of the topics interests you, go ahead and check it. Okay, so a quick outline for our talk. I'll start with a brief introduction on what are samples and how people navigate them and how they are retrieved from online collections. We'll be looking at how classification algorithms can help on organizing and sorted collections. Then we'll be looking at similarity, then on compatibility, and the final topic will be focusing on generating new samples, and yeah, a brief conclusion. So I guess we should start by a definition of samples. It's sampling is reusing portions of a sound recording to create new pieces of music, and they are normally manipulated to fit the composition at hand. And they are normally one-shot sounds, which are single events like a strike of a drum, a single note, a single chord, or also a sound effect. And they can also be loops, which are longer parts of audio that are meant to be repeated seamlessly. And these can have rhythmic and harmonic content beyond the timbral that one-shots have. In the 90s, I guess some of you are familiar with this kind of CDs. This is how sample packs were distributed. Each CD will have a specific theme or genre, and a lot of these became very iconic for a lot of genres. But currently, I think music producers get their samples from online large-scale collections of music-making material, and these collections are very different from each other, both in terms of the audio material that they have and in terms of the methods that are used for browsing them. So here on the right, we are seeing Freesound. This was developed in the music technology group of Universitat Pompeu Fabra. And I mean, this is one of the databases that I worked more closely with during my PhD. And because this is a community-driven database, so mostly anyone can upload a sound there, and it's not directed only at electronic music creation. And basically the way to search for a sound in Freesound is to do a textual query. You can have advanced search options where you can have some descriptions of the sound and filtering through it. But basically this textual search tries to find tags or the description or the sound or a title and retrieve the sounds that make sense with that query. One of the biggest issues here is that there is no enforcement of how to tag, of how to describe the sounds. Mostly because the sounds are very different from each other. You can have field recordings, or you can have a kick drum. And yeah, because there is not this enforcement, sometimes it's a bit complicated to find the specific sound you're looking for. On Splice, which I guess it's a more producer-oriented platform, these sample packs are normally organized by an artist or by a theme as well, and they are heavily described. So you can have the instrument, the Germans, the key, the BPM, and if it's a one shot or a loop. And again, you have quite some tags that are provided by the person that created the sound. And in this case, it's a very sort of restricted taxonomy, specifically targeted to electronic music creation. Most platforms, I guess, follow a similar typology. So this is sounds.com by Native Instruments, which also has a very similar organization. And finally, I would say Looperman is sort of the hybrid between Freesound and a collection like Splice, where most of the samples are directed to electronic music or to music creation in general. But because they are described by users, the descriptions are very different in between sounds. But then they enforce these tags that can be used to search with. So for tempo, for genre, for the instrument, and the key. The big issue then, I guess, comes a lot when you download the sample packs to your computer, and then it really looks like this very old school way of exploring sounds, which is hierarchical tree directories. So I guess if you have, for example, different sample pack providers, they can organize the sounds in different ways. So for example, here, this one, it's mostly organized in terms of instrument. But yeah, sometimes you receive a folder which just has a bunch of sounds and they are not even named, and you have to listen to them and tag them. And yeah, I think one of the big issues with the hierarchical tree directories is the fact that you can have a hi-hat loop here, for example. It sounds very similar to one in the, let's say, dubstep category. And yeah, I mean, they won't be closed at all if you try to search them through. And I think this leads to a very unintuitive navigation. And when you search, for example, for snare sound, what you get is basically this. You're just going through lots of samples. They mostly sound the same. All these next sound sort of makes you lose the focus of what you wanted in the first place. And on research, Anderson and these, they had this very nice history paper on conversations with expert users in music retrieval and research challenges for creative MIR. So they interviewed music makers on the Red Bull Music Academy and asked what were their issues when making music or browsing libraries. So one of the artists said, because you usually have to browse really huge libraries that most of the time are not really well organized. Another say, I easily get lost. I always have to scroll back and forth and it ruins the flow when you're playing. So he sort of identifies and this retrieval of the specific sound makes him lose the flow in the creative process. And finally, this one provides a solution. It will be even more useful to be able to search for a particular snare, but I cannot really imagine how. I need something short, low in pitch, dark or bright in tone, and then it finds it. So here he is asking for some kind of textual description that relates to his perception of the sound. And yeah, how can deep learning assist on describing and enabling the retrieval of sounds from sample collections? So I think one of the most obvious way is through classification. We can classify, we can use deep learning classification systems for providing tags to sounds that we have in a collection, as long as we have a trained model that allows to go from audio to one label. And yeah, I mean, there has been a lot of work in MIR towards this end. As long as there is annotated data, that we should be able to train a model that is able to take unseen data and create a tag for it. I've presented some work in instrument classification. The work of Boca and Matthew Davies has been very, very good towards the classification of tempo, finding the tempo of a music piece, but also works for loops. And on key, I guess the work from the lab of Gerard Wimmer has been working a lot on key classification using deep learning. And finally, on general, I would like to point you to the work by Jordi Pons et al., which is mostly into music audio tagging. But this is beyond genre, but it also includes some genre tags, which is basically how to automatically classify music in a lot of their characteristics. But again, as long as you have data with the appropriate labels, you can make a classifier that says this snare is bright or it's dark, as long as you have that kind of data. Yeah, I guess the next thing I would like to look at is similarity. And I think both the classification and the similarity are very well connected. The similarity is understanding it. Two sounds sound similar to each other. This has been also very studied throughout the music information retrieval. But I guess for you to have an idea, if you train a classifier on any of these tasks or on all of these tasks at once, you can sort of destroy the last layer of the model and expect like the previous to last layer to have learned some kind of representation of musical audio related to that task. Yeah, so you'll be looking at a value of vectors a vector of values that won't be very easy to use by default, but you can plug these sort of features learned by the network to, for example, a visualization system. Yeah, I think, and then finally, sounds that sound similar together, they will be together in this visualization space, obviously after some kind of dimensionality reduction technique, so that you go from quite some dimensions to 2 or to 3. And I like to present some nice works on this topic. One is Free Sound Explorer that was presented by Frederick Font. And it's basically, I guess it takes a lot of feature. I guess this is not explicitly using deep learning, maybe a more machine learning approach where you have handcrafted features that were designed by experts, but you basically try to reduce the dimensionality of all these features to the visualization graph. Yeah, you can try it if you search for Free Sound Explorer. This is a very nice way, I think, for searching sounds in free sound. Another work that I like to present to you is by Xavier Favori, and it's into search result clustering in collaborative sound collections. Again, it uses free sound. I'm a big fan of this platform, as you can see. But I guess the idea here is beyond plotting all the sounds into this 2D representation, he also tries to join together or connect together sounds that should belong into the same category in an unsupervised way, which is very interesting, I would say. So you take all these sounds. He experimented a lot of representations, but one was the pre-trained audio net, the VDG-ish net trained on the audio set, and basically taking the one before last features, he's able to come up with this space and also find things that sound well together semantically, or that are similar semantic. And it will be very nice to see something like this applied to a local users collection. Yeah, the next topic I wanted to look at is compatibility. I guess this is more when you're already in the process of making music. And let's say you have a loop or a music piece, and you want to find a new loop that goes well along with it. You don't want stuff that is out of key, out of tempo, or that has a very different rhythm kind of profile. You want to identify things that sound well together. And yeah, one work, machine learning again, was presented by Miguel Perez Fernandez. I saw him in the chat before. And yeah, he did some nice work on understanding harmonic compatibility and how the different models for harmonic compatibility are useful for sample retrieval. But yeah, again, it's not just harmonic compatibility. I think it's also a lot about timbre. So you don't want to have much frequency masking in between loops. You don't, it's also about rhythm. You want the rhythms to go well along together. On the rhythm side, I don't think there's much research, but it's an interesting topic to pursue. And Stefan Latner, he presented in also last year's Izmir, this very interesting work on drum sample retrieval by musical context. So there is these deep learning algorithms called methodology, actually, contrastive representation learning, where you are giving two different types of data, and you have these encoders, which are deep learning algorithms that take these high dimensional data and project into a latent space, as we've seen before. And I find this work very interesting. So he gives a full track and takes the drum samples that were used by that track, and it sort of forces both encoders to map them in similar places in the latent space. So then one thing you can do is you have, for example, drum sounds, and you want to retrieve them and you want to retrieve one track that maybe you can sample and then layer your sounds on top. And this will be able to do that by finding the track that's closer there. And the opposite, you're working on your track, you give it to the deep learning model, and it returns which drum samples would sound nice with the track you're creating. I guess now it's not as much compatibility, but this paper, it's normally known as CLAP, but it's large-scale contrastive learning, contrastive language audio pre-training with feature fusion and keyword to caption augmentation. What they do is they give audio on one side, and on the other they provide text. So it also allows for retrieving. It should allow, I haven't tested it, to retrieve sounds based on the textual descriptions. I will try this out, and I think this should be very interesting to see how this will work, retrieving sounds just by doing a text. If you can say again, I want a dark snare, all these things that the user said, if it will retrieve the correct snare or not. But again, there's a latent space, so things around there should be fairly similar, and yeah, let's hope it works. Yeah, and the final topic I'd like to call, which is very dear to me, it's generation. And I think the main thing about generation is that it can extend the retrieval task. When you're doing retrieval, you're sort of limited to the samples that are in your collection. But on the generation side, you are able to generate the in-between of the data that you have. And you can generate samples similar to the ones that you have in your database. There is a lot of very interesting work on this field. I'll be just presenting you two systems I've built during my PhD. And yeah, I mean, there's a lot of things, very interesting things happening. You should check also Ramires.ai that CJ will be talking in the next presentation, but I focus on drum synthesis using these high-level characteristics that come from a project called Audio Commons. These are timbral characteristics that have some semantic meaning. So brightness, hardness, depth, roughness, boominess, warmth. We've trained a model, a WaveNet-based model that learns to go from these features to sounds similar to the ones in my library. So yeah, let's see it. yeah, I think you got an idea of the system. Obviously, there's quite some room for improvement into the audio quality. Javier Nistal, he presented a paper in Izmir about this as well, on improving the audio quality, but it was trained with a very big data set. Here we just use, I think, 5,000, 10,000 sounds around that. Yeah, there's a lot of other research into this that you can look into that. Obviously, as you can see, this is for one-shot sounds. We then extended this work into loops, and what we provided as input were the timbral features. So again, these brightness, hardness, depth, roughness, etc. For each frequency band, because now when you're dealing with loops for drums, you have to use quite they have quite more information that has to be modeled. So you can sort of manipulate the timbre of the kick drum, the snare drum, and the hi-hat. We take these activation functions from the automatic drum transcription literature. So, I mean, you wouldn't give these to a music maker, but these are very easy to map from a MIDI signal, and basically just sort of says the probability of a kick drum, of a snare drum, or of a hi-hat to exist in that position. And we use the harmonic pitch class profiles, which are basically a description of the tonal content of a loop. And yeah, we were able to generate loops from this. I'll skip the example. Yeah, let's step up to the conclusions now. Throughout this talk, I think we have looked at some very interesting deep learning methodologies for browsing sample libraries in terms of classification, similarity, compatibility, and also generation. And I think future work, especially for audio developers, as we are, as I think this is our target audience. One very important thing I would say in deep learning models, it's the data that we have. And I think a lot of maybe some audio developers, they have access to high quality data from their company. And it will be very interesting to see it pop up on research and being provided to researchers and academia. And this would very highly impact the work that we're doing. One very obvious use case, I mean, I've been using Freesound mostly, and the audio quality is very different from, for example, Splice. And when we trained in a model that used the native instruments data, it sounded way better. And yeah, data quality and the amount really makes a severe impact. Then, I mean, all this work during the PhD, it was based on tables with results showing that this model works well, this model doesn't. And actually, I mean, the idea is to assist users, and we really need to evaluate this with the actual end users, and you won't provide them with a Python interface or something like that. You have to give them a properly implemented plugin. And yeah, I think that's a very important step. That's sometimes a bit hard to take when you're in academia and you have to publish papers and present your research. And that, I think you guys can help a lot. And it will be nice to see how these tools pop up into very nicely implemented plugins. And that's it for me. Thank you very much for your time. Hope the talk has been clear and that you have enjoyed it. I'm open for any questions, and you have my email there. If you want, you can contact me later to there. That's it. Thank you very much.
Awesome. Thanks so much, António. Super interesting. Yeah, you definitely were able to cover a lot of aspects there of the problem. And I think in some sense that it actually helped me a lot understand all the dimensions of what you can do kind of in the context of the loops and samples, right? I didn't even kind of think of all those different sub-problems. But yeah, if there's any questions that people want to ask now, go ahead and put them in the chat. We have maybe time for one question before we move on to our final talk, or if there's any questions from those on the call here. Yeah, it looks like no questions, so we'll move on to our final talk. Thanks so much, António, for your time and for sharing your work with us.